Hey guys, welcome back once again. It's your boy Freeman Codes here. I've been able to implement the queue-triggered function for the image processing service, and I'll be walking you guys through how I did it step by step, from retrieving the message from the queue storage, which contains the product ID, the unprocessed image URL, and the file name. Wow. I should as well include the container name, but yeah, whatever works for you. So when the queued message triggers the function, we will then decode the message text property of the message item to get the information which we'll be making use of to perform a set of actions in the image processing function using various Azure services. The first one being downloading the blob using the file name from the unprocessed images container, and then resizing the images, or rather resizing the image using a third-party library, before then uploading that resized image back to the processed images container, and then updating the processed image URL for the product item in Cosmos DB, and then deleting the temp file. Have you ever wondered what happens behind the scenes when you upload an image to a platform? Today, I'll be showing you how we could use Azure Functions to handle image processing securely, efficiently, and automatically. We'll be building a serverless solution that does all the heavy lifting. So let's get started. Before we dive into the code, let's take a quick look at the bigger picture of the image processing service and how it works. So we have the request coming in from the browser or from Postman, which is sent to the product processing function, which stores the product in the Cosmos DB, and then stores the unprocessed image in the blob storage, before then enqueuing the task in the queue storage. This enqueue task is what triggers our next function, which is the ResizeImageFunction. ResizeImageFunction then downloads unprocessed image, that is the unprocessed image that was uploaded initially from the container, and then resizes the image using a third-party package, before then uploading the processed image to a processed images container, and then updating the Cosmos DB product with the processed image URL. Alright guys, before I walk you through the ResizeImageFunction, I'll just give you guys a recap of the product processing function that handles the uploading of image to the container and creating of an item in the Cosmos DB. But if you want a detailed guideline of how I did that and the explanation of the code in proper details, you can check out the video in the description. So yeah, I'll just go straight into sharing my screen. Yeah, so over here I've got the product processing function. So in here we've got 4 actions which we are getting from the dependency container, which are already registered in the program.cs file. I've got 5 of them. 1 is being used for image resize. So we've got 4 just for the product processing function, which I stated here, and then we get them from the constructor of the function, and this is the run method which is triggered when there's a request to this function. And in the body of this function we've got we've got an else if, 2 conditions. We're first checking if it has form content type, meaning if it has an image, or if it doesn't, we just handle this as a JSON file, as a JSON object, sorry. So now once we've determined if it has a content type, we can then get the name, price, and quantity, check if there are files, ensure that the file is a valid image file, and then upload the file to the unprocessed images container, and then create a new product object using the blob URI that's returned from the action. This is the first action that we run. Then if it's just a normal JSON, we just deserialize the object. So it's going to be a normal product object, so we just deserialize it and create a new product object. So once we've done that, so this is just for retrieving a product object from the request. Once we've done that, we then proceed to creating a new product using the create product action. So we've got this is the second action now that is running. The first one is uploading image. The second one is creating product action, which creates the product using the product data which has been created, or rather deserialized from the JSON object or gotten through the product object that was initialized for form data content type. So when we create the product using the create product action, we then check if there's an unprocessed image URL, because the only reason why we want to enqueue a task is if an image was uploaded for that product, because the task we're enqueuing is for the processing of the image. So if there's an unprocessed image URL, meaning yes, we uploaded the image, then we create a new product image processing message. So this product image processing message here has product ID, the unprocessed image URL, and the file name. I would have included the container name here as well, but I didn't. So we will then create this processing message, which we'll then use as more like a tag to enqueue the task to the queue storage. But before we do that, I have to serialize it, so we can serialize it and process the message in the image resize function. So we just enqueue the task and then return a normal API response saying the product has been created successfully. So yeah, now we can create an item in the Cosmos DB container and upload the image to the blob storage while enqueuing the task for processing. We can then work on our function, which then gets that image from the blob storage, resizes it, and uploads it back to the blob storage while updating the processed image URL in the container. So yeah, let's get straight into it. So over here, guys, I've got my Funkify project. In the root directory, I've got the Funkify project and the Funkify.tests in the same solution file. Then to the right hand side, I've got the ResizeImageFunction. The ResizeImageFunction just has one action, which is the image resize action that takes care of every single thing that happens. I mean, yeah, of course, I could have made use of different actions for maybe downloading the blob and stuff like that, but I just decided to put everything in one function and used private methods to take care of those. So I've got the ResizeImageFunction, and this image resize action I've already defined in my program.cs file, which I then get in my constructor through the dependency container. And this ResizeImageFunction is triggered by the queue trigger. I've got various tests for all these, although I don't have one for the ResizeImageFunction. One reason being that for the image resize action, I covered as much test case I could. So you can check those out in my Funkify.tests project. So over here, I've got the test cases. I'm working the blob service and the Cosmos DB service and testing the methods as much as I can. So yeah, without wasting much of your time, I'll just walk you guys through the code. So in here, I've got the image resize action. This is a very simple function, to be honest, because I mean, you can see what I'm just doing here. I'm just logging what is happening, deserializing the object from the message text, which I mentioned earlier, and then using the image resize action to process the image. Then I'm just handling the errors. So this is a very simple, straightforward function. The action is doing all the heavy lifting. So in the action here, I've got two services which I'm making use of. I've got the blob service and the Cosmos DB service, which I already declared using interfaces, which I used interfaces and for the contract and then inherited from those interfaces to keep things streamlined. So in here, I've got the database name Funkify, the container name products, and this is where I declared the unprocessed blob container, unprocessed images. I would have gotten this from the message text, but I decided to, I just discovered I discovered this later on, but I could still refactor the code to, send this to the queue. So in here, I'm getting the blob service and the Cosmos DB service from the dependency container too. So I've got an extension method over here, which takes care of setting up my Azure services. So in my resize image action, I'll just double click this. I've got the invoke method. So yeah, I've got two invoke methods here. So I think the reason why I have this one here is because of the tests I wrote. So I mean, while I was writing tests, some of the test cases needed to just pass in the process blob's container name and the blob name without the item ID and the partition key. So I kind of created a variant to so I can then invoke the other one, the main function, by passing in empty ID and partition key. So in the invoke method, we'll first validate the inputs, which is here. We just check that the container name is not null and the blob name is not null. Once we've done that, we will then use the blob service to download the blob. So in here, I won't really walk you guys through the integrity, going in depth, but really just a quick overview. So in here, we've got the blob service, which takes care of downloading the blob, and we've got the code here. Sorry, the blob service. So this is the contract, which is the interface. So, and this is the download blob method, which validates the inputs as well. Then makes use of the blob container client to get the container, get a blob, ensure it exists before downloading it to a local file path. So it downloads it to a local file path. It's getting my current directory and downloading it to a local file path, which is still going to be deleted later on. That's how I implemented it. Then once it's done that, it returns that download path. That is the path it's downloaded it to. It downloads it to, I think, an images, a test. I can't remember what it downloads it to, but yeah, it just gets the directory, the root directory, and then downloads it to a subdirectory in there, and then passes that download path to the resize image private method in this particular image resize action class. So over here, I've got the resize image method. The resize image method gets that image path, uses the image that is image class from image sharp to load the image from the image path, and then mutates the image and just resize. So basically what I just did is just cut this slash the image size by half. You could decide to do more things. Once it's done that, it then creates a new, it then sets a new file name using the resized, assigning the resized underscore prefix to it, and then saves it to that resized image path and returns the resized image path. So in here, so once we've gotten the resized image path, we then open it as a stream to then upload it back to blob storage, because the upload blob method here needs a stream. It uploads the blob through a stream. So here we need a stream, which still basically does the same thing as the download blob, but it just gets the container, gets the blob. So the blob client requires a name, and then uploads the blob as a stream and overwrites it if it already exists. Once it's done that, it then returns the URI of the uploaded blob back to the function or back to the action. So the first, just a quick recap before I proceed. We'll first validate the inputs, download the blob, resize the image, like I said there. We'll download the blob, we'll resize the image, and then upload the processed image to the processed images container, which is this. And once we've done that, we will then update the product image URL in Cosmos DB by specifying the item ID and the partition key, as well as the uploaded blob URI. This is a private action as well, which is here. So just ensure that the item ID and partition key is not empty. Set up update using the dictionary, and then use the Cosmos DB patch items async method to only update what needs to be updated, which is just the product image, the product image URL, the processed image URL. So over here, we've got two methods, one for updating the whole item and one for patching the properties of an item. So over here, I validate the input as well, get the container, then create a patch operation by just determining what properties we are trying to update, which is just the processed image URL here, and then use the patch item async method, which needs the ID of the item we're trying to update, the partition key, and then the patch operation. Once it's done that, once it's updated the item, it then returns the updated resource. So we don't really need the resource for anything, but it just returns the resource. And then once we've done that, so this is the last step of the resize image action or the resize image function. We'll then delete the temporary files which we've created here, which are in the download part and the resize image part. Then that's all for the function, for the image resize function or the image resize action. Then in the resize image function, which is the entry point, we have the queue trigger. So the trigger, this function is triggered by the funcify queue, and the connection is through a storage connection string, which I defined in my locale.settings.json. I'll be getting into this later on while I walk you guys through testing the function locally and in production. So over here, we deserialize the object from the message text, ensure that the object is not null, and then this is just a logger. Use the image resize invoke method to process the image. Once you've done that, the queue doesn't necessarily return any, this queue trigger function doesn't return any value, so we just log what's going on. If there's an error, we log it, and that's it. So yeah, that's all about it for the image resize action. So now we've understood how the resize image function works. We have to test it locally. So over here, I've got my funcify queue, which is defined in my storage account. So to create a queue, all you have to do is just create a storage account first, Then head over to queues and create a new queue. I've got my queue here, Funkify queue, which can be accessed using the URL. And then I've got my connection string to access the queue. To get a connection string, head back to your storage account, and under access keys, you've got the two connection strings here, which you can then define in your locale.settings.json file. But before you do that, just have to reference something over here. So you see something about Azure Web Jobs. So when you define your settings, so assuming I define storage here, and in my locale.settings.json I have Azure Web Job Storage, it uses Azure Web Job Storage. If not, it defaults to this. This same setting or this same setting is what I'm using in production as well, but we'll get to that when we test in production. So now we've got this. We've got the queue triggered by the Funkify queue with the connection string set up in your locale.settings.json file. We can just go over to, we can just head over to running this function now. So I'm running this using function call choose. I came across there was an issue I've been facing over here with running the function. The function works fine, but there's a problem with duplicate names. I created an issue in the GitHub repository. If you've come across this before and you know a way or you've sorted it out before, just leave a comment over there, or kind of like let us know in the comment section so we all can learn. So but I'll still be getting back to this later on. That's why I created an issue in the repository. So I'll just go ahead and run this function. See, you can see we've got two functions, the product processing function and the ResizeImageFunction. So I'll be walking guys through the whole flow, because we need to create a request, we need to create a product first, to then upload, to then use the uploaded product image to trigger the ResizeImageFunction. So over here I've got the first function, which is the product processing function. Now you can see my body. Under the body I've got the form data selected. So I'll just create a new product. I'll call this Converse, or I'll call this Timberland. Then I'll set the price to maybe 250 and the quantity to 12. I've got an image already there. Then I'll just head over to my Cosmos DB database. So yeah, I'm using the trial version. Let's go ahead on. So yeah, I've got no products at the moment because I think I deleted all of them. So I'll just head back to my, oh sorry, I didn't show you guys. So this is my postman. I didn't know my postman was not in view. So this is my postman. I've got the product processing function. We've got the form data selected. We're sending in the name, the price, the quantity, and the image. I've set everything here, so I'll just go ahead and send this request, and you see it processed over here. So this is sending to this particular URL here, not the one in production. It's sending to this one here. So just go ahead and paste it over here again. Click on send. If we head back, you can see it's processing the request. You can see it's processing form data request and uploaded the blob storage as blob. You can see the product has been created successfully. I'll get back to that, but you can see now that the product has been created with the ID and the file name, which is what we uploaded. If you head back to Cosmos DB storage, you can see the newly created product. Also, yeah, because everything was seamless and very straightforward, it processed the image ASAP and updated the processed image URL. But I'll still come back to this. But so this is the created product, and over here in our console you can see the logs. So he first created the product and give us the ID, then enqueued a task for processing the image and returned an OK object result. Sorry. Once it's done that, once it's executed the product processing function, that queue, which was also set up over here, so he enqueued a message, but we can't see it here because it's already processed it. So he enqueued a message, which then triggered the ResizeImageFunction. He found out that there was a new message detected on Funkify queue, then got the message ID, got the message ID and the message text, deserialized it, got the product ID, the unprocessed image URL, and the file name. You can see the file name, remember from the, so I just head back to my things over here. So you can see the file name is the same as the other one. So he gets these details, then resizes the image and uploads it back to the storage account. So over here in my storage account, I've also got so I head over to containers. I've got the unprocessed images, which is this one, which was just uploaded. You can see it was uploaded by 3:45 p.m., which is just 2 minutes ago. And then I've got the processed images, which was uploaded by 3:45 p.m. And you can see this is 351 kilobytes, and the one which was uploaded as an unprocessed image is 1.26 MB. So you can see it kind of reduced it drastically. So yeah, that's all about it for that. So yeah, just to show you guys that everything's handled in different functions. I think a better case is to send a JSON object. When I send the JSON object, the queue triggered function doesn't run because there's no queue. You can remember in my product processing function here, we're checking if there was an unprocessed image URL, which is only added when an image was uploaded. So I'll go ahead and restart my function now. Head back to my Postman app and send the raw object. I'll set the name to new Max. Set the price to 900 and the quantity to 19. I'll go ahead and make this request. So over here, it processes the request as a normal JSON file, as a normal JSON object, sorry. And you can see here, it just created the image, it created the product and returned an object result without enqueuing a task. If you head back to the Cosmos DB storage, we can see the newly created product without the image URL because we didn't send an image through. So yeah, if you did send an image through using the form data type, it would have done the same thing, but uploaded the image first and then set the unprocessed image URL, then queue the task, which then triggers the queue triggered function, which then processes the image and updates the processed image URL. So yeah, that's all for that. Let's get straight into testing the function in production. So yeah, now the function runs locally, we need to test it in production. I have a new function app which I already created and also set up auto deployment using GitHub Actions. In my function app, we have two functions, the product processing function and the ResizeImageFunction. One is triggered through HTTP request and the other is triggered through a queue storage. Now we need to test the workflow and see how things work. I've stopped the process. I've stopped my local server from running so it doesn't process the queue. I mean, the product processing function, we're going to be making a request to the function apps domain, but this particular ResizeImageFunction is also connected to the queue storage in production, which is not right. I mean, I was meant to use Azure right for that, but you can decide to use whatever you want to use. But yeah, that's all about that. So I'll just go ahead now and make a request to the product processing function. Over here, I've got my ResizeImageFunction logs, which logs basically the same thing as the ResizeImageFunction in local dev. So when we make a request to the product processing function, it creates the item in Cosmos DB. Let me go ahead and just delete all this once again. So delete all the items. So it creates the item in the Cosmos DB database or container, enqueues the task in the Funkify queue, and then resizes the images in the ResizeImageFunction in Funkify. So now I have a new tab here which is the funkify.azurewebsite.net and calls the API product processing function. Similar stuff, name, price, quantity, and image. I'll send the request. Product created successfully. Head over to the Cosmos DB database, refresh. You have the newly created product. So over here you can see that the processed image URL is null because it's not been processed. If we refresh, we can see the queue has the queued message as well with the unprocessed image URL with the ID of the item that was created, which ends in 787. We head back here, you can see this ends in 787. Then the ResizeImageFunction is yet to process the queue, or is yet to process the queue message, or it has not been triggered yet, but it will be triggered soon. So let's just give it a couple seconds. So now the ResizeImageFunction has been triggered by the queue message which was added to this queue. So it's processed the image and uploaded the image to the blob storage. So now if you go ahead and refresh this, click on this again, you can see we have the processed image URL because it's processed it. And if you go ahead and refresh our queue, it's been removed because it's processed this already. I would have shown you guys the time, but if you can remember, if you can just, I think it was by tray 57 if I'm correct, and it processed it by tray 59. So yeah, it took a couple of seconds or minutes to process it. But yeah, that's all about it with function. I can go ahead and make another request to show that it works well in the function app. So I'll call this Adidas V2. It's created a new product. This should also run straight away. Let me refresh. You have the new queued message, which was created by 40009. So over here you can see that the queue or the image function has been triggered by that queue message and it's processed it. So you can see that it was inserted by 4009 and it was processed by 401, so it took about a minute to process it. So yeah, that sums it all up about the image processing service. Yeah. So yeah guys, now being able to build an image processing service using serverless functions deployed in Azure Function app and gain a better understanding of how to do this using the .NET isolated runtime, making use of various Azure services. If you found this video helpful guys, don't forget to like, subscribe and turn on post notifications for more videos like this. We'll see you some other time.